a few logistical details. We have muted all lines to ensure a pleasant experience for all that joined us today. Since this webinar is designed to be interactive, we will ensure ample time for you to ask questions of our experts after their presentations. You can either submit your questions in the Q&A panel on the right of your screen or tweet a question to @Syniverse using the hashtag VoLTELessons. That's VoLTELessons. We'll also give you a chance to share your experience and opinion with a poll. We're also recording today's session and we'll make it available to all of you along with copies of the slides early next week. With the growth of LTE coverage and penetration, as well as the increased usage of LTE smartphones and devices, operators are now prioritizing the launch of LTE voice services. With 442 commercially launched LTE networks in 147 countries, the mobile industry has achieved great success with 755 million LTE connections through only the first half of last year. Now mobile operators are making the move to advance the VoLTE market with 111 operators investing in VoLTE deployments. Already 30 operators in 21 countries have commercially launched VoLTE-based HD voice services, and the Global Mobile Supplier Association announced last November that 246 VoLTE-capable devices, including 224 smartphones, have been announced. I'm sure we can expect more announcements next month at Mobile World Congress. As you can see on this slide, 83% of carriers surveyed by Infonetics say they will deploy VoLTE by the end of this year, 2016, and that 600 million smartphone users worldwide will use VoLTE by 2018 as their default voice service. And the latest reports from Hot Telecom tell us that VoLTE roaming minutes of use will grow by a CAGR of 145% over the next 5 years to reach 4.7 billion minutes of use by 2020. Clearly, there's market demand, so today we're going to cover what's driving the move to VoLTE and look at some of the best practices and key learnings you should be keeping in mind as you plan your implementations. Today, with the help of our guest speakers, we're going to address the question and share some of the best practices Syniverse has learned in helping manage some of the first implementations of VoLTE roaming services, including the world's first transoceanic VoLTE roaming call for US and Japanese operators in March, the world's first commercial VoLTE roaming service in April, giving subscribers of South Korea's LG U+ the ability to roam onto the KDDI network in Japan, and in September, LG U+ extended its commercial VoLTE roaming for subscribers to the SmartTone network in Hong Kong, again, using the Syniverse IPX network. So, you'll see on this next slide a quick question we'd like to ask you. Please know that your responses are completely confidential and we won't be sharing any company names in the responses. We just want to get a feel of where our audience is in their thinking today. We're going to give you 30 seconds to provide your response. The question should have appeared in a pop-up on your screen. We'd like to know, what is the most important driver for you for implementing VoLTE roaming? Is it real-time call control, such as prepaid, richer voice services, such as HD voice, competitive differentiation, all of these, none of these, or is it something else entirely? So again, you should have a pop-up window, and we'd appreciate if you can share completely confidentially, and we'll be able to share the results with you collectively as far as what the trends are, or what the overall views are of the audience that's participating today. So we're continuing to look through this. Again, the choices: what's the most important driver to you for implementing VoLTE roaming? Is it real-time call control such as prepaid, richer voice services such as HD voice, competitive differentiation, all of these, or none of these? Clearly, it looks like the answer clearly for most of you is all of these. Beyond that, though, competitive differentiation seems to be the driver, so the ability to differentiate yourself from your competitors within your market. I appreciate you sharing that information, and as we move on, hopefully we'll help you understand how to do that better, how to differentiate yourself from your competitors in the market. To do that, without further ado, I'm delighted to introduce and hand over to our speaker to hopefully address some of the concerns you may have around these next generation services. So I'd like to introduce our speakers. First will be John Wick. He's responsible for the management and growth of Syniverse's IP, SS7, and number portability product lines. John joined Syniverse in 1993 as a senior critical support analyst with the Network Operations Department. He's held management positions in operations, research and development, technology, and Six Sigma groups before moving into his current position. Prior to joining Syniverse, John was a systems integrator with Verizon and an electronic communications and switching systems technician for the U.S. Air Force stationed in Wiesbaden, West Germany, and San Antonio, Texas. After John, we'll have George Lamb. George is Syniverse's Senior Sales Director for the Asia-Pacific region. With over 15 years of solid GSM international roaming experience, George spent 12 years with 2 major MNOs in Hong Kong and has held responsibility for maintaining more than 600 global roaming partner relationships. George was the founder of the Connexus Alliance and the first chairman of the Connexus Roaming Group. Now, before I hand this over to John, a quick reminder that we'll be addressing any questions you have at the end of the session. If you have something to ask our speakers, please submit your questions in the Q&A box on the right of your screen, or again, tweet them to us at Syniverse using the hashtag VoLTEtrends, VoLTEtrends. At this point, John, feel free to jump in, and thank you for taking the time to join us.
Thank you, Mike, and good morning, good afternoon, and good evening to all of those that are attending the webinar. Thank you. Before we launch into the discussion on VoLTE roaming, I thought it might be helpful to take a few moments to clarify the difference between a couple of common terms used with VoLTE. That would be VoLTE Interconnect and VoLTE roaming, both of which utilize the IPX to make them work. Looking at the illustration on the screen, on the top half of the chart, we're showing what's referred to as VoLTE Interconnect. This is a non-roaming method where 2 VoLTE subscribers of different network providers place a call or a video session or some IMS use case to one another in their respective home markets. So think of this as making that international long-distance phone call between Japan and Korea or Japan and Singapore. This is where VoLTE Interconnect would come into play. Instead of using the traditional TDM long-distance network, you would actually make that phone call or video session or file share using VoLTE. On the bottom half of the screen, we talk about VoLTE roaming. So this requires a subscriber to travel to another operator's network and place or receive calls. So it's a very standard roaming model that everybody's familiar with. This is where we're going to focus on for this webinar. Within VoLTE roaming, there are 2 approaches that have been implemented to enable VoLTE roaming, known as S8 home routing and local breakout. We're going to talk about both of those models in this webinar. So let's go ahead and dive in and look at the advantages and challenges that each of these bring. The first model that we're going to look at is home-based routing, also known as S8 home routing. With S8 home routing, VoLTE calls are served by the visited network provider over an LTE data roaming session, so similar to how the internet traffic is supported, by leveraging the visited network provider's evolved packet core. Important distinction here is the serving network doesn't necessarily have an IMS deployment, and this is probably why S8 home routing would be an attractive option to enable roaming, and that is why the home routing part becomes important. The absence of IMS in the served network means that if you backhaul the traffic over the S8 interface to the home network, you can now do VoLTE calls, video sessions, and other use cases. So VoLTE roaming using the S8 home routing model is quickly gaining momentum with effectively a 5-to-1 ratio in favor of S8 home routing over local breakout, which we'll talk about on another chart. Some of the advantages that come with S8 home routing, so it's faster to deploy than local breakout, or also known as LBO. And as we discussed, it's because it uses the same GTP tunnel that's used for LTE data roaming traffic. So if you already have an LTE data roaming relationship in place with somebody, and that other network makes the evolution to an IMS network, you can now do VoLTE using S8 home routing. So it utilizes the same components that are already in the evolved packet core. So as we've already discussed, the VPMN does not have to have a full IMS core capability to do VoLTE roaming. It can use the same data IoT charges with roaming partners. So again, the existing data roaming agreements that you already have in place can be leveraged to enable the VoLTE services. And then it also uses existing TAP and RAEX with only minor changes. So if we think about some of the challenges that come with this model, lawful intercept and emergency calling. Lawful intercept, it allows the home network, but not the visited network, to do any kind of lawful intercept or lawful assistance when it comes to calling. There are also issues with emergency calling, and one of the reasons why this challenge exists is if you think about making a phone call, you dial the digits and then you hit send. In today's environment, that call is processed by the network that you're roaming in. If you're using S8 home routing, that call is actually being processed by the home network. So if you dial an emergency call, like a 911, for example, those digits of 911 have to be interpreted and processed by the home network. That home network, depending on the geographical definition, may or may not recognize those digits and be able to process that call. So these are just one of the things that have to be worked around. In some cases, 3G fallback is leveraged for these emergency calls. There's also issues with voice call continuity. And this is with regard to moving from a VoLTE session to a circuit switch session. And call handoff can be an issue. And then there's no service visibility for the VPMN, the served network. Because all activity is being enabled by the home network over the S8 interface, the served network really only sees packets of data flowing out the S8 interface to the other network, not really knowing if it's internet access, phone calls, video sessions, or whatever. And then finally, because we are now leveraging SIP protocol to enable a lot of the sessions, it's not distinguishable within the SIP traffic where an SMS is. So you lose visibility to SMS traffic, which in today's environment or in the 3G environment, you can certainly identify over SO7 or SMPP. So those are some of the challenges and the advantages of S8 home routing. And again, this is the popular method that's gaining momentum today and by a factor of 5-to-1. So let's jump ahead to the next chart and talk about local breakout. With this VoLTE roaming method, the VoLTE call control and the bearer components are served by the visited network provider's call and process servers or the IMS network. So one thing you'll notice right away with local breakout, the serving network and the home network both have IMS core components. So differing from the previous model of S8 home routing, the serve network is now capable of doing all of the IMS services that in the previous model were dependent upon the home network to complete. So what that means is when you are roaming into the VPMNA network, making phone calls, receiving phone calls, video sessions, file sharing, these can all be processed and handled by the serve network without having to route them to the home network over the S8 interface. Same protocols are used, SIP and RTP and diameter, but just a different call flow. And again, primarily driven by the capabilities of the serve network and the home network, both having IMS core capabilities. To talk about the advantages of local breakout over S8 home routing. So with local breakout, you now have session awareness in the serve network. And if you recall from the previous model, since everything was enabled by the home network, all the serve network could really see were packets flowing out of their network towards the home. So visibility into the control and the media plane of the call or the video session taking place is a possibility with local breakout. So as you probably have already guessed, you now have the ability to offer lawful intercept and emergency call handling. So the responsibility of completing calls or video sessions is now in the hands of the serving network, no longer in the hands of the home network. So there's no longer an issue with digit translation for dial digits that may not be recognized, as we discussed in S8 home routing. The continuity of a voice call between LTE, VoLTE, and circuit switched is no longer an issue because the serving network is now handling all call sessions. If you move from the LTE bearer to the circuit switch bearer, that network is responsible for handoff, and it's not a problem. And then again, support for the billing model tap for the retail billing. So this is an advantage again because all of the call activity is directly visible to the serve network. Challenges, complexities. So getting these two networks to work together can be highly complex. The complexity of interworking of the SIP protocol is highly underestimated, I would say. It's a very complex scenario of bridging SIP between two IMS core networks. And that's why you see the box in the middle in the IPX orange area called the IMS exchange. And as you'll hear from us during the webinar, we've already encountered situations where SIP complexities arise and interworking was needed to make two networks work together. That's how you think about that IMS exchange platform. It's there to adapt differences in interpretations of SIP. It's there to do vocoding and transcoding, and it's also there to do interworking with the diameter protocol. So the IMS interoperability challenges are many with local breakout, but again, this is where the IMS exchange platform is very useful to address those. So it requires multiple feeds from many network elements for both the serve network and the home network. And then local breakout for VoLTE with S8 home routing for data adds complexity. So again, it's probably a smoother model to do local breakout, but it's more complex to make it work, and it requires equal investment on both sides. And then there's new tap record types that will evolve to determine whether you're dealing with a mobile session or a messaging event. And those are not used today, so those have to evolve and become more widely used. So those are the advantages and disadvantages across S8 home routing and local breakout. So why don't we move ahead and talk about some lessons learned. So we've been actively working with mobile operators to trial and commercially launch VoLTE roaming services. And what you see here are some noted announcements that we've made recently in regard to these activities. First transoceanic VoLTE roaming session. So collaboration with an American and Japanese operator, we enabled the world's first transoceanic VoLTE roaming call based on the S8 home routing architecture. Established VoLTE roaming between South Korea and Japan. As Mike mentioned, LGU Plus subscribers from Korea roaming onto the KDDI network in Japan. Very exciting. Launch of the world's first commercial VoLTE roaming service. So again, with our friends at LGU Plus subscribers from Korea roaming onto the SmartCo network in Hong Kong. So during these trials and launches, we've gained valuable insight and firsthand experience, as well as learning a few lessons about what to expect when launching VoLTE roaming. So we'd like to share some of the key lessons learned with you. So connection setup and call quality are better than 3G. Hopefully, many of you on the webinar have had a chance to actually experiment with VoLTE, and you can understand what we're saying here. But specifically during the transoceanic call trial, we were pleasantly surprised to learn that despite slight connection delays and latency introduced from the S8 home routing, the latency, the call setup, and the call quality are all better than 3G. And by the way, that applied to voice calls and video sessions during that trial. So even though we were routing all of the traffic from the served network to the home network and then out to another network, we still observed better than 3G experience across voice calls and video sessions in both directions. So real-time control of voice traffic eliminates the need for CAML. So many services that require CAML can be provided natively by the home operator's IMS core. When operators gain real-time control, they have more opportunities to control fraud. So a very important enhancement to be sure. Handsets do not default to VoLTE when roaming. So this is something that we learned, and we always make sure that it's discussed early on. But it's easy to assume that the handsets will automatically use VoLTE when they're roaming, but that's not the case. So it's important to make sure that you identify what handsets you're going to use, and then make sure you communicate with the handset vendor to ensure that the devices are going to favor a VoLTE signal when they're roaming. So there were a lot of assumptions that the home operator would support lawful intercept, and as we've already discussed, depending on the model that was used, in this case, S8 home routing, that's not necessarily a valid assumption. So work needs to be done there in the planning stages for trialing and launching to make sure that you've got the appropriate tools and solutions in place to make sure that that's not a gap. And then, of course, charging for VoLTE needs to be worked out by each operator. And as an example, some operators charge LTE data IoT rates for VoLTE. And if operators prefer a different IoT, they must distinguish VoLTE from LTE. To do that, you've got to get down to the APN or QCI level in the data, and which may or may not be an issue for some networks, but being able to distinguish traffic streams based on access point name or quality connect indicator is how you would do that. So let's move on to the next chart. So operators must understand how their roaming partners support S8 home routing. So we talked about the QCI codes in the previous chart. It's important that the QCIs are standardized between networks. Even though QCI is standardized in the 3GPP standard, we've seen evidence that they can be configured and used differently between networks. Certainly, do not expect that to change. And so this is always something that either the two networks have to address during conversation or require that the IPX provider address that in the middle for them. The maximum bit rate for each QCI can be configured differently per operator. And you must understand the number of APNs and which APNs can be supported per QCI by your roaming partner. So you get down to some pretty specific details in terms of how the networks are going to respond based on access point name and which QCIs to apply based on the access point name. The video calls started during voice calls, difficult to distinguish by VPMN. So it appears as another data flow, so two separate tap records are created. The home network needs to consider correlation of records for retail billing. So again, the need to look at the access point names and or the QCI values to really be able to understand what kind of use case is being used per session that's generating a tap record to understand how to rate that record. And then as we mentioned before, the SMS traffic is viewed as signaling, so it's just part of the SIP stream. And if signaling is not charged between roaming partners, then SMS is no charge. Again, this may open some opportunities for messaging spam. There are certainly solutions out there in the marketplace to address messaging spam. We certainly get into that business as well, but again, the fact that SMS is moving into a different signaling stream here, the SIP signaling stream, the visibility of that is limited, and then the change from SS7 signaling to SIP signaling can potentially have different commercial terms between partners. And as we've illustrated here, if those commercial terms are very light, then it may open the door for some spam on SMS. But just something to be on the lookout for sure. Okay, that wraps up my part of the webinar, and I think at this point I will turn it back over to Mike to introduce our next speaker. Thank you. Mike?
Hey, thank you, John. It was really helpful and interesting to hear the difference between SA home routing with the speed of deployment, but limitations on some features and billing versus local breakout, which had more comprehensive service features, but leads to complexity of both implementation and interoperability. So appreciate you helping us with that understanding. To continue the discussion, I'm delighted to now hand the presentation to George Lamb, who's going to share a case study that Syniverse has been working on with a leading mobile operator within the Asia-Pacific region who has implemented bilateral VoLTE roaming using S8 home routing.
Okay, thank you, Mike. Good morning, good afternoon, good evening to all attending this webinar. Thanks for your time. Before I start, I just noticed before I start this webinar, I browsed through the name list of attendants, and I noticed there's quite a few friends who have joined this call. So hello to you all. Great to have you here. I'm going to spend the next 50 minutes in presenting a case study of a VoLTE roaming trial using S8 home route, which has been facilitated by Syniverse. This, by no means, is the only case. It's a very typical case that we have done. Syniverse, we have done quite a number of trials already in VoLTE roaming. Most of them are in this region in Asia. This does not come as a surprise that, in fact, most of the VoLTE service domestically actually have launched within the Asia region. So naturally, there's more VoLTE roaming activities happening in this region. So just some background to this typical trial. It was done between two Tier 1 operators in Asia back last year in 2015. So both of these operators, they have launched domestic VoLTE service and also commercial LTE roaming. And this is quite important because it's without the launch of commercial LTE roaming, without the established data path, it would require much more work to be done to do any VoLTE trial. So it was already in place before the trial started. And one more interesting point to note that is for this trial, one of the operators have also launched a local VoLTE interconnect with other mobile operators in the domestic market. So that also forms part of the test items within the trial as well. And I think as far as we know, this is probably the one of the very few countries in the world that two LTE operators with VoLTE have done interconnect. So both have unanimously decided to choose S8 home route over local breakout for reasons that John has just pointed out previously, for much quicker deployment, minimum changes required to the network, to the user device, and also to the billing systems. And the scope of this particular trial for these two operators actually is not only a trial. It's right from day one that commercial launch will happen after the trial is done and after all the hiccups and problems have been resolved as a result of the trial. So right at the very beginning, both have been looking at their production network to make sure they are both ready for the VoLTE roaming after the trial. And during the trial, one of them are using their own lab IMS and using a Syniverse production IPX for this service. And at the time, well, still is actually, there isn't that many commercial handsets that can support VoLTE roaming at the moment. You might see some handsets in the Japanese and the Korean markets, but typically they are domestic handset models in the domestic and Japanese market, in Japanese and the Korean markets, that they do not make them available outside these two countries. So as far as I know, there are only very few handsets that can support VoLTE roaming at the moment. But I'm certain expect this will come, particularly this year. And so when this particular trial was done, the handset actually is not a production model handset. It's a prototype handset requested by these two operators from their vendors, specifically made for this trial. Next slide, please. Okay, so this slide is what needs to be done before the trial to start. Is a kind of a checklist at a high level that for the operators to look at before what they need to prepare for the trial and the subsequent commercial launch. So the IMS, so the operators need to decide whether what IMS to use. Basically, there's a choice of either operators can use their own production IMS, or if they have such facility, the lab IMS for the trial. Or alternatively, Syniverse have our own lab IMS environment based in Tampa and in Singapore for operators to use if necessary. So there are three options, and for Syniverse, we've done all the three options, so it's up to the testing operators their preferred choice of preference. And since production IPX is used both for the trial and the subsequent commercial launch. So both the home network need to ensure that it is connected to the production firewall or the edge router, so it is connected to the Syniverse IPX network for all the lab or the testing or the production traffic. And for the trial, because both customers are using Syniverse IPX as well as the diameter signaling service, so we have the ability from our diameter proxy to reroute the test traffic, SXA, to the lab facilities of the HPMN if necessary. And for the user plane traffic, and if the HPMN, the home network, decide to use their lab facility, so they have to ensure the user plane traffic from the production network need to be routed to the lab facility. This is normally done at the firewall or at the DEA, which I will show you a slide later on. And of course, just like the normal IRAC testing process, but this time is different because the handsets are very likely are proprietary. So both the test SIM cards and the test equipment need to be sent to the visitor network for testing. Because there's no commercial, as I said earlier, because there's no commercial handsets available that can support VoLTE roaming. So the home network need to send their own test device to the visitor network. And of course, the test plan for SA home mount, because it doesn't involve the IMS interworking, is quite straightforward actually. At the moment, unfortunately, there's no GSMA standard test plan available yet for SA home mount. There is one for local breakout or VoLTE interworking. That's the NN.25, but it would not be suitable for this particular scope. And of course, if necessary, Syniverse do have a template which can be provided to operators if necessary. Next one is on the tab on the billing side. It's in order to prepare for commercial launch, the VPMN and the HPMN need to ensure that they are on the latest tab version 3.12 to support the QCI values in core type level 2. And also because the nature of SA home mount, it does not support duration-based charging at the retail level. So operators who normally use tab for retail billing, this one will not work. They will need to look at their own IMS for the appropriate CDR for retail charging if they wish to continue using duration-based retail charging. So this is something the HPMN need to look at their billing systems. What needs to be done in order to support the legacy duration-based charging if necessary. Next one at the network side is the support of VoLTE roaming for the MME in the visitor market. This is particularly important, is during the attach accept procedures to support the IMS voice over PS indicator and the emergency service support indicator. So this needs to be supported at the VPMN MME. Right, so next one is the, sorry, can you go back to 16? Yep, yeah, thank you. So this one is the architecture, it's the roaming architecture. It's a typical scenario where the user plane and the control plane traffic is carried over the IPX network. And at the bottom, note that is a VoLTE interconnect that this particular HPMN has done a IMS interworking with mobile operators in that country. Next one, please. And this is a routing of the test environment where the HPMN is using a lab IMS. So on the left-hand side is the production network. So at the firewall, the user plane and the control plane traffic is rerouted to the lab facilities IMS. Yes, please. Next one, please. So some high-level key findings. As expected, the voice quality, because of the wideband AMR codec, is much better than in 3G. And also, the call setup time is significantly faster than in the 3G because of the flat architectures of the EPC and the shortest path of setting up the call between the home and the visitor network. Next one, please. So some key issues we have identified from the trial is the better voice quality for both the mobile originating call and the mobile terminating call for both the calling and the called party. And it would also give the ability, because it's over data, the ability for the HPMN to charge different pricing based on the QCI or the APM value, if so wish. And also this, as we would expect, like the early days of camera roaming, this would be an appealing factor to other roaming partners who are looking for better service for their roamers in a visited country. And on the network side, what we have identified is some networks do not necessarily support multiple QCI values for inbound roamers. If this is not supported, then the QoS for VoLTE and VoLTE video in LTE may not be able to be guaranteed. Next one, please. And just emphasizing on John's previous deck is the user equipment, which we see is one of the major issues that we have identified. It's a combinations. There are two ways of doing emergency call in VoLTE. One is using an emergency PTN, which is a VoLTE call localized to the visitor network, or CS fallback. And handset and the visitor network are supposed to support both. But it may not be the case. Some would support only PTN and some would only support CS fallback, and likewise for the device. So the two operators who intend to launch this service need to sit down and then look at the device, look at their own network, and decide how to overcome this and what is the best method. And the other one is also, if a visitor network does not have VoLTE agreement with the home network, for example, they have not agreed or done any tests to launch VoLTE roaming, then the visitor network, MME, they need to ensure that the IMS voice over PS indicator during the attach accept procedures is not sent to everybody. They need to do it selectively to only those inbound roamers who they have a VoLTE roaming agreement with. Otherwise, it would cause a lot of traffic overloading at the MME, and it would take the device much more time to do a successful attach accept in the visitor network. Next one, please. Charging. So since the 1st of November, the TAP version 3.12, the call type level 2 need to be supported for home network to identify how those calls are, and are they VoLTE call or are they normal data call? And also the APM must be equal IMS. This is a 3GPP requirement that the visitor network must able to support, because all the VoLTE APN is mandatory to be IMS. Lawful intercept, as John said earlier on, unfortunately there's no there is 3GPP requirement and standard for local breakout, but in the case of SA tone out, there's no standard yet, although the 3GPP they are now working on. So maybe it's probably the best path for a lawful intercept requirement is probably at the S gateway of the VPMN. And it may be also advised to check the local regulatory requirement of the VPMN, what's the requirement for lawful intercept. Is it required for inbound roaming or only required for their domestic customers? every country have their own different regulations. So this needs to be checked. Next one, please. And again, further on the emergency call handling on the device. Now, 112 is the well-known standard emergency code for all GSM networks. But each country have their own specific emergency numbers, like 911 in the States, 999 in Hong Kong, Singapore, and UK. So the device, they do not have this information, and they do not know. And because all the call goes back to home, so the home IMS need to determine what to do with this specific localized emergency number. So there are two options that we identify. One is the HPMN would reject the call, so to force the handset to go to either emergency PTN or CS fallback to dial a standard 112 emergency call. To do that, the HPMN IMS may need to have a database of all the emergency number of all the countries. The other options is during the attack, except the VPMN may send their local emergency code to the handset. So the handset will remember this is the emergency code that needs to be supported in that country. Next one is the short code, the VPMN short code and the premium numbers. For example, some visitor network may offer a short code dialing like 8294 for taxi. And for this type of call, the HPMN would not know. So they may have to, again, have a database, if it is important, to store this particular short code so they can do a number translations if necessary. Next one, please. Now, last one is, sorry, I didn't put in the slide, is SRVCC, which is not being supported in SA home route, although, again, the 3GPP is working on. This may be a considerations if a VPMN has a spotty LTE coverage, then it may run the chance of very likely the call will be dropped because it would not be able to hand over back to a 3G network. So again, this is something the operators may have to consider. So thank you. That's the end of my presentations. I'm just handing over to Mike for the Q&A.
Hey, thanks a lot, George. Got it. Thanks a lot, George. We've accumulated some great learnings from the work that Syniverse has already done in the space, and I hope that, that the information was helpful to all of you and gave you some good insights to take back into your own business as you plan your implementations for these advanced roaming services. As George and John were speaking, we had a couple of questions come in. As a reminder, if you have questions, please submit them in the Q&A box on the right of your screen, or, again, you can tweet them to us at Syniverse using hashtag VoLTEtrends. At this point, I'd like to go to our first question, which, very helpful. With S8 home routing, does voice and data have the same quality of service, and what occurs if the GTP tunnel is full or congested? George, do you want to answer that one for us?
Yes, please, Mike. Okay, thanks. Now, actually, in the IPX spec, IR34, there are support of various QoS for various type of service. So it all depends on how the sending network mark this data packet on the DSCP markings. How they mark their data packet would label how they label the priority of this type of traffic. For instance, in the IPX for Syniverse, and as in GSM standard, we support the highest grade, which is what we call the expedite forwarding, EF, and to the lowest, which is called BE, best effort. So if the operator sending the data packet, the labeled with the correct DSCP marking with the EF grade, then we will send those traffic with the highest priority over the IPX. So it doesn't matter whether it's voice or data or video or anything. It all depends on the DSCP markings. So operators, of course, naturally, they will most likely mark their DSCP for voice with the highest quality, the EF, and the lowest data, for example, email with the best effort, the lowest quality, and then we will route those traffic accordingly over the IPX, according to their priority assigned by the sending network. And now the next question is, what happens if GTP tunnel is full and congested? In fact, in IP world is not exactly the same as circuit switch. Circuit switch, you have a finite capacity. You have one circuit, 64K channel, you use it, that's it. But for IP, it has a high tolerance. So you can still fit more traffic in the IP channel, but it's just the quality will be degraded. So in this case, if it will not be full, it will be congested. And so if there's a case scenario, despite the various QoS marking of EF and BE, if the IPX is congested, if the customer say he's having a 100 meg bandwidth, but he's pumping in 500 meg of traffic, then how this is handled, if all those traffic with the EF marking, they will always go first. Otherwise, others will wait. Right. So, but if you come to a threshold, even of all the available bandwidth has been assigned to EF are still full, then there will be a severe degrade of quality of service. However, for Syniverse IPX, well, actually, I'm the one that doing this myself, is we proactively monitor the utilizations of all our IPX customers for the congestions. If we see there's it's reaching the threshold or the maximum, we will proactively inform the customers to let them know there may be a need to increase the bandwidth in order not to suffer a bad quality of service. Thank you, Mike.
Thanks, George.
I've answered the question.
Thanks, George. Actually, very helpful. Some of the other questions we've got in we'll address back directly with the people who have asked them. There was one question regarding pricing of VoLTE roaming calls, specifically roaming calls. And what I would tell you is pricing is information that is decided by each operator individually. I would suggest if you're looking for someone's specific pricing, you'd check their tariffs that they've had either published or what they're advertising at this point, because we really can't share pricing information. The material itself from this presentation will be shared with everyone in the next few days when we publish the webinar itself. A few other questions that came in privately. One of them, what are the value propositions to operators for offering VoLTE roaming services? Again, George, do you want to take a shot at that?
Yeah, I'll do that. Thanks, Mike. Well, there are quite a few advantages for operators to adopt VoLTE roaming. Well, first of all, it's a natural evolutions for service to go along. And this would be, I mean, roaming service has been around for quite a long time, and basically it's a more or less a commodity service where a home network from in a certain country, A, B, C competitors, they are all offering the same service when they go to a foreign country in roaming. And this would give the opportunity to distinguish or stand out by providing a higher quality of service to their customers by providing by doing the VoLTE roaming. One particular advantage is for, I think, there's no argument that roaming nowadays, most of the traffic coming from the high ARPU customers are the enterprise or the corporate customers, where they would have a very high demand of the service quality. And if they are used to the high quality VoLTE service domestically, then I think naturally when they're roaming, they would expect more or less the same the more same quality of service as well. And also, it would all depends on the relationship and the IoT arrangement of the home and the visitor network. Now, by doing this, there may be a potentially lower cost for outbound roaming because of the data structure of the data tariff, which is traditionally is cheaper than voice. So there's one option there. And also, this is the first time. Now, one thing is LTE IMS does not support Camel. And there are still some operators would require real-time charging via Camel service, more specifically for their prepaid customers. So as LTE does not support Camel, there need to be alternative if these operators would like to continue to offer roaming service to their prepaid customers. The ability of S8 home mount, the real-time call control would allow operators to do that. And on the topic of real-time call control, then apart from real-time charging, it can also be used for other applications. For example, all the IDD routes to third country when roaming are now controlled by the home network instead of the visitor. So it would be much more easier for troubleshooting and for maintaining the quality because they can use their own selected IDD routes for that. And also, for monitoring, I mean, near trade now is 4 hours risk exposure. But with this real-time control, it's instantaneous. So it would significantly lower the risk exposure of operators to roaming fraud. And real-time call recording may be just another example that I can think of. Some financial regulators, for instance, Hong Kong is for one, that require certain financial houses to have real-time recording of their customers, be it a local or a roaming. Previously, to do that, we required Camel. So the abilities of the multi-home mount would able to help operators to serve this very important segment of the roaming market, which is the financial guys who are always willing to pay the bill for roaming. And I'm sure there will be a lot more as we come along. I just got this right from top of my head. So let's see. Okay, thanks, Mike.
Thanks, George. We've had a few more questions, but unfortunately, we're actually out of time at this point. We've captured all of your questions, so what I would tell you is for those of you who have asked stuff that we haven't gotten to, we'll definitely be getting back in touch with you. We'll reach out to you. But in the meantime, we're out of time for the Q&A section. I do want to thank both John and George for sharing all the information with us for the best practice tips. Hopefully it's something you can help with. What came through loud and clear is that VoLTE roaming is inevitable. It's coming. It's happening today. We're at the early stages, but it's part of the next generation that everyone will be dealing with over the next 3 years. So at this point, you need to have it on your radar and you need to have it in your plans. We know there are additional challenges to overcome regardless of the model you choose, as discussed, but no implementation in our industry has ever been without a few challenges as we transition from one generation of technology to the next. But the benefits to both the operators and to your end customers are actually clear and will easily outweigh any of the negatives. So as we said from the start, the session has been recorded. We'll be sending a follow-up out early next week with the slides on SlideShare, a new infographic we've developed with some more key learnings, and we'll also share additional information as far as Q&A for those who have asked. We'll share that as well. At this point, feel free if you'd like to follow us for extended topics on both today's blog and others at synergy.syniverse.com. And there you can sign up to receive our latest blog posts directly into your inbox. At this point, I'd like to once again thank our speakers, let you know we appreciate the time you guys have spent with us today. If you have any follow-ups for us, feel free to send them to info@syniverse.com. That's via email, info@syniverse.com, and you can continue that discussion. You can also reach us via Twitter, @Syniverse is our handle, or on LinkedIn or Facebook. So again, thank you all for taking the time today, and thanks to George and John for all of their insights.